for years, tech companies basically managed to avoid strict artificial intelligence governance. And they did it by hiding behind this very specific, very convenient technicality.
Yeah, a massive loophole, really.
Right. They would sit across from regulators and just say, look, our software doesn't rewrite its own base code, therefore it's not truly AI, and your rules don't apply to us.
And, the crazy part is that for a long time, that excuse actually worked perfectly.
It really did. But today, we're diving into the exact policy document that legally dismantles that excuse. Welcome to today's deep dive. We are looking at the revised DGPSI, which is the Data Governance and Privacy Security Initiative, their AI definition and governance framework.
Right, and just to set the stage for you, this is a highly specific, fundamentally important manual. It's what auditors and companies actually use to figure out what systems need to be governed and exactly how to do it.
Because the previous version of this document, well, when it was compared to the Supreme Court's AI framework, it became glaringly obvious that the old DGPSI definition was just full of ambiguities and gaping holes.
Absolutely. The challenge they faced was how to modernize their definitions, but without losing their core philosophy.
Right.
Because DGPSI's distinctive strength has always been focusing on the actual loss of human control over a system, rather than, just ticking off a rigid checklist of technical features.
Okay, let's unpack this, because the revised framework meticulously fixes 4 specific flaws from the old rules. And for you listening, understanding how they fix these flaws is crucial.
Yeah, whether you're developing these systems, auditing them, or honestly just living in a world where they make decisions about your life.
Exactly. So we're going to trace the path the system takes through this new framework, starting with the core definition that determines if it's AI at all, then moving to the accountability threshold that triggers the rules, and finally looking at the distinct risk classes.
So the first step is what the document calls the core definition. This is basically the gate.
The bouncer.
Right. Before we can even talk about how to govern an AI, we have to determine if the software actually qualifies. So the framework defines an AI system as an automated data processing system that, for a given input, produces decisions, predictions, recommendations, or content.
Which, on its face, that sounds like almost any basic software. Like if I put a formula into a spreadsheet to predict next quarter's revenue based on past sales.
Yeah.
That is technically an automated system producing a prediction, right?
It is, but the operative clause follows immediately after that. The defining characteristic of AI, according to the DGPSI, is that these outputs are not fully predetermined by explicit human-authored instructions.
Oh, yeah.
The system has to derive or adapt its own processing logic from data, models, or probabilistic methods.
That is the dividing line. So think of traditional software as like a really strict recipe follower.
That's a good way to put it.
Right. If you give a computer explicit human-authored instructions to bake a cake like, if this, then that, bake at 350 degrees for 30 minutes, it will do exactly that every single time. It only knows the parameters of the recipe.
Exactly. It can't improvise.
But this new AI definition, it describes a chef. A chef looks at the ingredients in the pantry, the data, and derives their own processing logic to create a dish.
Yeah, they might use probabilistic methods, which is essentially mathematical guessing, to figure out that, a pinch of salt will enhance the chocolate.
Right, even if no explicit instruction ever told them to do so. The output isn't predetermined by a developer's code. It's derived by the system's own internal logic.
And if we connect this to the bigger picture, defining the core this way solves a massive international headache.
How so?
Well, the source text points out that this new definition sentence was written to intentionally mirror the descriptive boundaries used by the OECD, the EU AI Act, and the draft Supreme Court framework.
Oh, wow. So a developer isn't dealing with completely competing foundational definitions across different jurisdictions anymore.
Exactly. Interoperability is the key benefit here. A company building a machine learning model doesn't have to argue that it's, an AI in Europe, but just advanced statistics under DGPSI standards in another region.
They're finally speaking the same foundational language.
Yeah.
That makes so much sense.
It really does. It streamlines the whole compliance process.
Okay, so we've established that was in the kitchen deriving their own logic. But just simply being an AI doesn't automatically trigger the heavy governance requirements of the standard, does it?
No, it doesn't. That requires crossing what the document calls the accountability threshold.
Right, and you mentioned this earlier. I like to think of this less like a bouncer at a club and more like an autopilot disengagement warning in an airplane.
Oh, I like that analogy.
The governance really kicks in the exact moment the human pilot takes their hands off the yoke.
Yeah, exactly. The framework states that the standard applies when the degree of meaningful human intervention falls below a specific threshold.
Okay.
And it applies this test of intervention to one of two areas: either the formation of the output itself or the application of that output to a real-world decision affecting a person, a business, or a legal outcome.
See, I have to play the skeptic on this one for a second.
Go for it.
Because as I read the section on meaningful intervention, it sounded incredibly subjective to me. Like, who actually decides what meaningful means in practice?
That's the million-dollar question.
Right. Because if a loan officer just blindly clicks approve on an AI-generated mortgage denial without actually reading the file, they technically intervened, didn't they? Under the old rules, that ambiguity seemed like a massive liability.
It was. The old rule suffered from what the text calls the undefined acceptable threshold. It was just this vague philosophy that companies could easily exploit.
So how did they fix it?
The new framework solves this by making the threshold procedurally determinate.
Meaning it shifts from a theoretical debate to, like, a mandatory process.
Precisely. The burden is now placed entirely on the deployer of the AI system. They are legally required to define and record exactly what constitutes the accountability threshold for each specific system.
Oh, wow. So they have to write it down.
Yes, and place that definition securely in their risk documentation. They have to state, for the record, what meaningful human intervention looks like for their specific tool before they ever deploy it.
That raises an immediate operational question, though. What happens if a company fails to document that threshold or, intentionally leaves it ambiguous to avoid scrutiny?
Well, the framework actually includes a built-in trapdoor called the default presumption.
The default presumption.
Right. If the deployer fails to document the threshold, or if the system hits any of the high autonomy characteristics we'll talk about in a minute, the framework automatically defaults to assuming the accountability threshold has been crossed.
Oh, so governance just becomes mandatory automatically.
Yeah. Exactly. It assumes you've lost control unless you have the paperwork proving otherwise.
Making it a paperwork requirement definitely gives it real teeth. But, it also sounds like a pretty heavy bureaucratic burden, especially for, smaller startups trying to deploy basic models. If they don't file the right risk docs, they're legally presumed to be operating autonomous systems.
The text actually addresses this. It points out that this dovetails with DGPSI's existing deviation justification document discipline.
That's a mouthful.
It is, yeah. But basically, the baseline expectation in critical digital systems is human control. If you are going to deviate from that baseline and let a machine drive, you must rigorously justify and document it.
I see.
The bureaucracy is basically the price of autonomy.
That's a great way to frame it. Okay, let's follow a hypothetical AI system through this framework to see how this works in practice. Say a major bank deploys an AI to process business loans.
Okay, classic use case.
The system crosses the accountability threshold. The bank admits the AI is approving or denying loans with minimal human oversight. How does an auditor actually know what specific risks to look for?
This brings us to the three classes of systems. Classes 1, 2, and 3.
And I noticed an unstated assumption when I was reading this part that I really want to challenge. Usually when regulations use a numbered tier system, like class 1, 2, and 3, it represents a ladder of severity, right?
That's a normal way of doing it.
Like class 1's a minor issue, class 2 is medium, and class 3 is a critical emergency. Is that how this works?
What's fascinating here is that the framework explicitly warns against that interpretation. That was actually the second major ambiguity they had to fix from the old rules.
Oh, really?
Yeah, the revised text clarifies that these classes are independent risk vectors, not an ascending scale of severity.
So a system in class 3 isn't inherently more dangerous than a system in class 1?
Not at all. They just pose entirely different types of risk. Furthermore, they aren't mutually exclusive. A single AI system can exhibit the characteristics of Class 1, Class 2, and Class 3 simultaneously.
Oh, wow. So they stack.
Exactly. The actual severity of the system, meaning whether it's classified as low, medium, high, or critical risk, is determined by a completely separate risk tier matrix that looks at the impact of the decisions, not the class number itself.
Okay, let's look at how these risk vectors actually manifest in the real world. So class 1 covers adaptive or self-learning systems. The framework defines this as a system that alters its own decision behavior without a human developer revising the underlying logic for each change.
And this is where the document explicitly closes the loophole we discussed at the very beginning of the show.
Yes.
The text calls this fixing the code-correcting literalism.
Right. This was the excuse that conventional machine learning didn't need governing because it didn't literally rewrite its own source code.
Exactly. So the new phrasing broadens the definition of altering decision behavior to match how modern AI actually functions. Class 1 explicitly includes systems that adjust their own parameters, weights, rules, embeddings, or operative prompts.
I think we should explain how that works mechanically for you listening, because that mathematical shift is what triggers the governance now. When they talk about adjusting and embedding, what are they actually looking at?
Right, so an embedding is basically how an AI translates human concepts like words or images into mathematical coordinates in a vast multidimensional space.
So it turns words into math.
Basically, yeah. Words with similar meanings are grouped closer together in that space. As a conventional machine learning model processes more training data, it might shift those coordinates over time.
Okay.
It might change the statistical weight it gives to a certain variable in a loan application, for example.
But the code itself hasn't changed.
Exactly. The underlying source code written by the human developer hasn't changed a single line. But the system's fundamental logic, how it weighs data to make a decision, has profoundly altered itself.
Wow.
So by specifically naming weights and embeddings in the rulebook, DGPSI completely dismantles that literalist defense.
That is so smart. Okay, that brings us to class 2, which is autonomous action or automated decision systems. Now, the risk vector here isn't necessarily that the system is learning on its own, but the velocity at which it executes.
Right. Spot on. The text describes this as a system whose output is applied to a decision affecting a person, business, or legal outcome without a human being able to review and override that specific output before it takes effect.
So going back to our bank loan example, if the AI analyzes the application and mathematically decides to deny the loan and then automatically fires off the rejection email and updates the database before a human officer can hit a cancel button.
Then that is a Class 2 system. The core issue there is the physical impossibility of intervention in the specific transaction. It's happening too fast.
How does a deployer practically prove to an auditor that they aren't a Class 2 system then? Like, how do you prove a negative?
They have to prove operational latency.
Operational latency.
Yeah, they must demonstrate that the system holds the decision in a queue, providing a functional, human-accessible interface with a genuine override capability before the API call to execute the action is authorized.
Okay, so there has to be a physical pause built into the system.
Right. If you can't prove that operational pause exists, you are legally operating a Class 2 autonomous system.
Which introduces Class 3, generative and effective systems. Now, these are systems that generate novel content, so text, images, audio, video, or code. Basically, the standard large language models and image generators we're all used to seeing in the news.
Yes, but the text goes significantly further than just standard content generation.
Right. Here's where it gets really interesting. The second half of that Class 3 definition includes systems that infer, simulate, or respond to human emotional or behavioral states.
The effective system.
Yes. The inclusion of these effective systems feels like a massive leap forward in how auditors understand risk. We aren't just looking at the risk of an AI generating a fake image anymore. We're looking at the risk of an AI manipulating a human being.
And effective computing is a rapidly expanding field. I mean, these systems can analyze microexpressions through your webcam, they can measure the cadence and pitch of your voice, or track your biometric responses.
Which is slightly terrifying.
It is. The AI uses that data to infer if you're frustrated or vulnerable or highly suggestible, and then it dynamically alters its conversational prompts to exploit that emotional state.
So the risk isn't just the content it generates, but the behavioral outcome it's engineered to elicit from the user.
Exactly. And that precise realization is what forced the final and perhaps most significant architectural shift in the entire document.
Okay, tell me more about that.
The drafters had to explain why Class 3 is structurally separated from Classes 1 and 2.
Which addresses the fourth ambiguity the text points out. The mismatch between the headline philosophy of the standard and the actual classes operating underneath it.
Right. See, the previous iteration of the framework attempted to view the entire AI landscape through a single lens, which we can think of as the control axis.
The control axis.
The baseline assumption used to be that all AI risk stems from human intervention falling below a threshold. Classes 1 and 2 fit neatly onto this axis, right?
Fair.
If the system is adapting its own weights, you've lost a degree of control. If it's executing decisions faster than a human can override, you've lost control.
But a generative system doesn't really fit that mold.
Not at all. Generative and effective systems produce emergent, unpredictable risks, regardless of the level of human control.
Right, because even if a human developer is tightly controlling the system's guardrails, and, say, a human user is carefully crafting the prompt and reviewing the output before publishing it, a Class 3 system can still hallucinate fabricated legal cases.
Exactly. Or generate deeply biased imagery, or manipulate a user's emotional state, like we just talked about. The risk does not stem from a lack of human oversight.
Right.
It stems from what the system is inherently capable of doing.
So the revised architecture openly rests on two independent foundations now.
Yes. The framework establishes the control ground, which governs classes 1 and 2 based on the loss of meaningful human intervention. And it establishes the capability ground, which governs class 3 based purely on the system's inherent design.
And the source material notes that the framework fixes the earlier philosophical slippage by simply acknowledging reality.
Right.
It states explicitly that either ground is sufficient on its own to bring a system under the standard.
Right.
So an auditor doesn't have to prove a company lost control of their image generator to mandate governance. The mere fact that it has a generative capability is enough to trigger the rules.
Yeah, it creates a much more intellectually honest standard. It stops trying to force every single piece of technology to fit the exact same human intervention test.
And what makes this document particularly useful for auditors in the field is how it compresses all of this complex philosophy into a short-form version for the actual body of the standard. It perfectly summarizes the three distinct triggers.
A quick reference guide, basically.
Exactly.
Yeah.
A system crosses the threshold into strict governance, if it's really. 1, adapts its own decision behavior without per change human revision. 2, applies a binding decision without a human able to override the specific output. Or 3, generates novel content or responds to human behavioral states.
It translates pages of nuanced theoretical debate into a clear, actionable mandate for compliance teams, which is huge.
So what does this all mean for you as a learner navigating this space? The primary takeaway is that the DGPSI framework has evolved from a vague, buzzword-heavy concept into a tightly defined procedural gauntlet.
A gauntlet is a good word for it.
It forces deployers to formally document their intervention thresholds,
Right.
completely removing the excuse of ambiguity. It shuts down the technical loophole that AI must rewrite its own source code to be governed.
Yeah, that literalist defense is dead.
And crucially, it recognizes that systems executing autonomous decisions pose a fundamentally different type of risk than systems designed to simulate human emotion. Both require rigorous oversight, but they require entirely different auditing toolkits.
It is an undeniable step forward in regulatory clarity, but, if we analyze the long-term implications of this text, it leaves us with a highly unresolved paradox regarding the future of that very oversight.
Wait, really? What kind of paradox?
There's a real tension built into the very foundation of these rules. The entire control ground of this framework rests on measuring meaningful human intervention and documenting when a human loses control of an execution.
Okay, sure.
But as these Class 1 adaptive systems and Class 2 high-velocity systems scale up, we're talking processing millions of transactions, a second human being physically cannot monitor those accountability thresholds.
Right. The sheer velocity just completely outstrips human cognitive capacity.
Exactly, which means deployers are already building and deploying other AI systems to monitor the governance thresholds of their primary AI systems.
Oh, wow. So we are entering an era of AI auditing AI.
We are, and this raises a fundamental question that the document doesn't yet answer. If an AI model is tasked with determining whether meaningful human intervention occurred in another AI model, does the legal concept of human control just become another automated parameter?
That is wild to think about.
Right. Have we actually preserved human oversight, or have we simply outsourced the measurement of our own control to a machine?
That is a fascinating point to end on. It suggests that the framework we just unpacked, as robust as it is today, is built on a definition of human intervention that the technology itself might soon render completely obsolete.
It's definitely something to keep an eye on.
Well, thank you for joining us on this deep dive. For you listening, keep asking those hard questions, examine the mechanisms behind the technology, and most importantly, always view the information landscape critically.